So as mentioned, this will be the last section that's covered on Tuesday's test. 2.3 is exponential functions. So we're going to start talking about characteristics of exponential functions, how to identify if something has growth or decay, and how to manipulate them a little bit. We get into more manipulation in the next section, which will be on the next test. But for 2.3, obviously it's all exponential, so not linear. This just says an exponential function with base a is denoted by f of x equals a to the x, where a is greater than 0 and a does not equal 1. So the base on an exponential function has to be positive. It can't be 0. It can't be 1. Otherwise, it would be constant. What you have to pay attention to is like what values are there, because sometimes the a is the base and sometimes the a is like a scalar multiple. The a will be on the front and then it would be b to the x. And it will ask you to give characteristics of a and b. So pay attention to where those variables are. Because a is a scalar multiple, right? Like a is something that would cause a vertical stretch or compression. B is the base of the function. B would be your rate of change. If it asks for r, or if it asks for, is it proportional? Yes, and by what rate? That would be your b. The b is the rate of change, okay? A can be, in this example, in the one on the bottom where it's a times b to the x, a can be negative, but the base itself, whatever's being raised to the exponent, cannot. What's being raised to an exponent can be a whole number, a decimal, a fraction, okay? So this guy can be a decimal, a fraction, or obviously a whole number, but it has to be positive. This is what you would worry about changing the sign. If that's negative, what does it do to a graph if I put a negative on the front? Flips it upside down. So in a parent function of an exponential function, if my base is a whole number, it is increasing as I move from left to right. If I put a negative on the front, it's going to flip it upside down. So it would be decreasing as I move from left to right. Okay, so all of the manipulations that we do, we'll come back to again in the next section. We'll do a little bit more with the horizontal translation, vertical translate, that kind of stuff. But the negative is important to understand in this section. So the graphs of your exponential functions have two different classifications, which are exponential growth and exponential decay. They are exactly as they sound. Growth is something that gets bigger as you are going from left to right. Decay is something that gets smaller as you go from left to right. So if your base is a whole number and what's on the front of it is positive, then your growth is going to happen. As you move from left to right, your graph is going to increase. So in this case, this A and this B that they're referring to would be the A on the front and the B being raised to the power. So if A is bigger than 0, that means A is positive, and B is bigger than 1, that means it's a whole number. Or even if it's a fraction, it's an improper fraction, because that can happen too. Then you have exponential growth. If A is greater than 0, so again, the number on the front is positive, but B is between 0 and 1, now we're talking fraction or decimal between 0 or 1, then you get exponential decay. So you will simply get a question that gives you a formula, and it will ask you, does it have exponential growth or decay, and why? And that's usually your 4 multiple choice. It's got exponential growth, it's got exponential decay, and then why? Because A is bigger than 0 and B is in between 0 and 1. If A is bigger than 0 and B is less than or greater than 1, those kinds of things is what you'll see. That's how they take something that should be very easy and very easy to explain, and they'll give it 800 words in its description, okay? So example 1 says determine if the function is growth or decay, and then justify your response. So first of all, note all of the A's are positive. That's the first thing that you can note, which means there's no reflection. So now we're really just focusing on our B. In A, our B is, there's two, either bigger than 1 or in between 0 and 1, right? So which one is it? It's in between 0 and 1, which means it has what? Decay. So this one would have decay, and it's because A is greater than 0 and B is between 0 and 1. It will have a whole lot more words than that if it's multiple choice, but that's basically what you're looking for. Now go to B. Again, the A is positive, so I'm really focusing on my B. What's true about B this time? That 2.3 is in between 0 or 1 or bigger than 1? Bigger than 1. So does this growth or decay? Growth. And again, because A is greater than 0 and B is greater than 1. And then go to C. A is again positive. So I'm looking at B. Is B in between 0 or 1 or bigger than 1? It's bigger than 1. So even though it's a fraction, it's still bigger than 1. Don't let that fool you. This would have growth or decay? Growth. Because A is greater than 0 and B is greater than 1. Questions on any of those? All right, example 2, it says the following values are output values of an exponential function of the form f of x equals a times b to the x, where a and b are constants. Write the function along with the input value that represent the output value. A lot of words again, right? All you are doing is writing a function along with the input value that represents this output value. So if I look at A, I get 3 times 3 times 3 times 2.5. When I am building an exponential function, which would repeat, the A or the B? The B, because you're raising to a power, right? Good morning. Yep. So if your B is raised to the second power, then B is going to repeat twice, right? If the B is raised to the third power, then the B is going to repeat 3 times if I expand it out. So really what we're looking for is what repeats, that's your B. How many times does it repeat? That's your exponent. That's your input value. And then what's the scalar? That's your A. So if you look at example A, what repeats? The 3. So the 3 is going to be your B or your R if it was in geometric, okay? And how many times does it repeat? 3. That's your input value. So that's how many times we're going to multiply it out is what was put into the exponent. This is my B, okay? And 2.5 is my A. So it would be 2.5 times 3 to the x. So the 1 repeats is your B. That gets the exponent. The scalar will be by itself. That's your A. And then however many times it repeats would be your input value in that scenario. So go to B. What's going to be your B, your base? 0.3, that's the one that repeats, right? So 3.5 is your A, so 3.5 goes first, times 0.3 raised to the x power. How many 0.3s are there? Again, 3, so x would be 3. So it's weird, but it should be easy once you understand what you're doing. Questions on those? All right, now let's talk about these functions. So characteristics of every exponential function. They are either always increasing or always decreasing. Their direction will not change. Obviously, if it's got exponential growth, it is always increasing. If it's got exponential decay, it is always decreasing. Which means there's no max or min. There's no extrema. And that means that they are always concave up or concave down. So if my graph is increasing because it's got growth, it's exponential growth, okay? Does that shape look like a U or an N? A U, that would be concave up, okay? If it is exponential decay and it is decreasing, okay, is that shape different? Does that change to an N? No, it's still concave up. What will change is if it's got a reflection. If it's got a reflection and it flips over your x-axis, now it has the N shape, and that would be concave down. Okay, so that's the difference between. But again, the entire interval will either be concave up or concave down. It will not change, which means it has no inflection points, because an inflection point is where it changes from concave up to concave down. So if the input values increase or decrease without bound, then the end behavior is going to be expressed in specific ways. Think about what could happen here. If my input values increase or decrease, which is what this means, it's like on either side, then my graph could either look like this, okay? So if it's approaching infinity and it's going, let's do this one positive. So in this case, if my x was approaching infinity, which means it's going to the right, what behavior could my arrow have? In this case, my arrow is doing what? going to positive infinity here, right? What if I asked if it was going to negative infinity? If it's going to negative infinity, what could be happening there? It's approaching my horizontal asymptote, yes? So it could be 0. If there's a vertical shift, which is really what we'll get into more in the next section, that's when you will see that change. If there's no vertical shift, then the end behavior on one side is always going to be 0. It just depends on which way it's facing. And then, what's your other option? Well, what happens if this is decreasing, okay? Now, the end behavior on the left is still 0, but what's the end behavior on the right? It's negative infinity. So those are your 3 options. Depends on which direction it's facing. It's either going to be infinity. This should have a negative, sorry. It's going to be infinity, negative infinity, or 0 until you start to do a vertical shift. If you do a vertical shift, then that 0 changes, okay? So really only 3 options there. God bless you. All right, so example 3 says, given f of x equals 2 times 3 to the x, and answer the following questions. Is it increasing, decreasing, concave up, concave down, and then find your end behavior. So what would 2 to the 3x look like? It's got exponential growth. Is there a vertical shift on this sucker? No, which means my horizontal asymptote is at 0. That's going to help me with my end behavior later. And it's got exponential growth. I actually need to know no exact values. I just need to know what it looks like overall. So is this function increasing or decreasing? Increasing. Is it concave up or concave down? Concave up. What's happening as it approaches negative infinity? It goes to 0, good. And as it goes to positive infinity, it goes to infinity. Questions so far? All right, example 4. Now what's different? There's a negative on the front. What's the negative on the front do? Flips it over the x-axis. First of all, it's still got growth because the base is still 3, bigger than 1. But instead of it going up like this, right, it is flipped over your x-axis, so it's going to look something like that. So is this function increasing or decreasing? Decreasing. Is the function concave up or concave down? Concave down. What's happening as x goes to negative infinity? Goes to 0. And as it goes to positive infinity? Negative infinity. Yep. So if there is no vertical shift, you always have a horizontal asymptote at 0. Like adding or subtracting something after the function or separate from it. So if that said negative 2 times 3 to the x plus 1, now my vertical shift causes my vertical asymptote to move. I mean horizontal asymptote. Does that make sense? So as long as you're not adding or subtracting anything, your horizontal asymptote's at 0. All right. Last one like this. 2 times 0.4x. Okay, so the 0.4 is now your base. What's that causing? It's exponential decay. Good. So as I'm going from left to right, my graph is falling. Increasing or decreasing? Decreasing. Concave up or concave down? Concave up. What's happening as it's going to negative infinity? Infinity. And as it goes to positive infinity? 0. Good. All right, so here's again, like, okay, here's some application. Now it's going to take something that's pretty simple and it's going to overcomplicate it because it's going to add a whole paragraph worth of words. Okay, on your AP Classroom, it's going to ask you to compare a function and then like a parent function and then its shifted function. So think about what it's saying, because this could change, but this in this specific example, it's saying g of x equals to f of x plus k. And we just said k would be an added on or subtracted, right? But what that does is causes a vertical shift. So if I add 3, it's shifting everything up 3. If I subtract 3, it's shifting everything down 3. We understand that part so far, right? Okay, So then the next thing says, if the output values of G are proportional over equal length input values of intervals, then f of x is exponential. So go back to the last section and think about how we knew if something was exponential. We would look at our y values and we would see that they are proportional, right? The second one over the first, the third one over the second, the fourth one over the third would be proportional. So what this is saying is that if my output values at the end of my g of x, if I had whatever I have here, if these values are proportional, then my initial function has to also have been proportional. But what is not necessarily true is the other way around. Just because I have an initial exponential function does not mean its shifted graph is also proportional. So if I took, like, if you think about it, if I said this, like if f of x, or if I said g of x equals f of x plus k, what can you tell me about g of x and f of x? And it's going to give you, like, it's the first question on your AP homework. It's going to give you multiple choice, and it's going to say if f of x is proportional, or the output values are proportional, then g of x also has to be proportional. If g of x is proportional, then f of x has to also be proportional, okay? If the adjusted function is proportional, then the original one has to be proportional, but not necessarily the other way around. And think about why that happens. If I have a function that says f of x equals 2 to the x, right? What would my output value, let's say x is negative, no, let's start, just do 1, 2, 3. 1, 2, 3. What are my output values? So 2 to the first would be what? 2. 2 to the second is 4. 2 to the third is 8. Are these values proportional? Yes, right? 4 divided by 2 is the same thing as 8 divided by 4. We agree on that, yes? So if the function itself is exponential, then I know the output values are proportional. But what happens if I take that function and I add a vertical shift to it? Let's just say I have shifted up 3. That means all those values, same, let's say same input. X to the first is 2 plus 3, this is 5. X to the second is 4 plus 3, that's 7. X to the third is 8 plus 3 is 11. Are those values proportional? No. 7 over 5 does not equal 11 over 7. So just because your parent function is exponential and has proportional values does not mean a shifted will stay proportional. Does that make sense? Okay. So that's like a weird multiple choice question. And I would say in scenarios like that, if you have no understanding of what they're saying, do what we just did. Take something and compare, plug in some points and compare the values and see what would be true. Okay? The beginning part of this homework, I think the PDF part is pretty easy. The AP Classroom throws in stuff like that where you have to really think about the application and it makes it complicated. Questions overall on anything today or yesterday's homework? Okay.